This is section 9.3. This is the last example. It's kind of a word problem. It gets you more into the physics area of where we use our Algebra 2 skills. So we're going to have a train, and it's going to travel at one velocity, and then it's going to change velocities and continue on. So we have our initial velocity and then our second velocity, and we're going to start at v1, and then we're going to move on to v2. So we could be traveling along and we're going this velocity and then we speed up and then we're going to go at this velocity. Or we could be going at a really fast pace and then we hit a city and then we've got to slow down. So that's what we're talking about. This would be your V1. This would be your V2. So let's look more about this problem in specific. So then we've got a T1 and a T2. And so that's the amount of time you're spending at the first velocity and the amount of time you're spending at the second velocity. And our equation for this is going to be the V is going to be equal to V1 times T1. So velocity times time would be equals distance, right? Distance equals rate times time. So that's just our rate times our time. Velocity is a rate and time. This is our velocity and our time for the second part of our trip. And then if we add our times together, that would give us an average velocity over the trip when we divide. So we're given some information for our problem. T1 is going to be the independent variable. Time is always your independent variable, and time goes on your x-axis, which means our velocity is going to be our y-axis. So we're actually going to have a v-axis and a t-axis in this problem. So independent variable is your x-axis. Dependent variable is your y-axis. Draw the graph if V1 is 50. Okay, so let's start filling some stuff here. V1 is 50. We don't know T1. Our V2 is 30. Our T2 is 1. And then we don't know T1, but we know T2. So that's what our equation looks like when we filled it in. Our only variable left is T sub 1, our amount of time we spent for the first part of our trip. So first thing first, what is our asymptote, if any? Well, we've got this T plus 1 on there. We don't know if it factors out or what we've got going here. If we look at the top of our fraction, there we've got 50t plus 30, right? And 50t plus 30, it's not like we can factor out the same number and end up with a t plus 1. So it looks like our t plus 1 is going to be what it is. So we can just leave it that way. So that makes it an asymptote or a hole. Well, let's go back up here to where we defined asymptotes and holes, right? And our asymptotes is when it was left in the equation, and our holes are when they cancel out, right? So this one is being left in the equation, so it is an asymptote. So come back down to our problem. We've got an asymptote. The asymptote is t cannot be equal to, let's make sure we're going slow here. T sub 1 plus 1 cannot be equal to 0. So that means T sub 1 cannot be equal to negative 1. So we're going to have an asymptote at negative 1. Okay, I paused for just a second there. I changed out my graph. I noticed that if my asymptote's at negative 1, I probably need to have this in such a way that I can actually get to a negative 1. So now I've got my asymptote in there. And my asymptote of negative 1, maybe I won't be counting by ones, maybe I will be counting by ones. Oops, this is not going to work. Why don't I do a dotted line for now? So let me grab a dotted line for my asymptote here. So my asymptote's going to be at negative 1. Oops. I'm just all over the place here. Yeah, let me delete that out of there. Okay, go back to my arrow. So my asymptote is here, and we might need to move that back and forth wherever that one happens to be. If we're counting by tens, I might have to put it really close here. Right now, I'll put it at -1, so it'll work for us for now. There are no other things in our denominator, so we don't have any holes. No holes. No holes. And then we want to find the v-intercept of our graph. So we're going to need to maybe do an x and a y table here, which is actually a v and a t sub 1 table. So t sub 1 is our x and v is our y. So if I put in a 0 would make that 30. 50 times 0 is 0 plus 30 would just be a 30 over 30 plus, or 0 plus 1. So that's just going to be 30. If I put in a 1, that's going to be 50 times 1 plus 30 over 1 plus 1, which is 2. So that's going to be 80 over 2, so that's going to be a 40. If I put in a 3, I'm going to have 50 times 3 plus 30 all over 3 plus 1. So that's 150, 180 over 4. And 180 divided by 4 would be a 45. How about a 4 or a 5? Let's put in a 5. Let's go bigger and see what's happening out there further. So 50 times 5 plus 30 all over 6. 5 plus 1 is 6. So 50 times 5 is 120. It would be 250. Plus 30 is 280. So we have 280 divided by 6. So that would be 24, be 40. 6 goes into 46. That'd be 36. So it's going to be 46 and 2/3 because the 6 is going to continue repeating. So 46 and 2/3. And you can see that we're getting close to a number, but we're not actually touching it. So it looks like we're going to have another asymptote here, one that's going horizontally. So let me plot in the points we have so far. At 0, we're at 30. So maybe I need to count by tens here. So 10, 20, 30, 40, 50, 60, 70, 80. And I'm just going by ones in my x direction. So at 0, I'm at 30. At 1, I'm at 40. At 3, I went to 45. At 5, I went to 46. So what's happening at -1/2? So that would be 1/2 of 50 is 25 plus 30, and 1 plus 1/2 is 3/2. So that's going to be 55 over 3/2, which is 55 times 2/3. It's getting kind of ugly here. So I need some more space. 55 times 2 is 110 divided by 3. 3 goes into 11 3 times. 11 minus 9 is 20. That would be a 6. It should be an 18, which would be a 2. Could be a 20. So it's going to be 36 and 2/3. Clean that up here, out of here. So that was a 0.5. I'm at 36 and 2/3. That can't be right. Hold on a second. Never mind, I'm fine. That is actually right. I was on the wrong side of my axis here. So 36 and 2/3 is right in here. So that's the right place to be. But I want to try a negative 1/2. That's where I was meant to try. So negative 0.5. So that's going to make that a negative 25 plus 30 over 1/2. So if you take 1/2 and use 1 minus 1/2, you get 1/2. So that would be equal to 30 minus 25 is 5 divided by 1/2. And 5 divided by 1/2 would be the same thing as 5 times 2. So that would be a 10. So I'll be putting my 10 down here. Okay, so you can see that we're going to get close. And our curve is going to go there. And we're going to get ever close to 50. And we're going to get ever close to 0. If you're not sure about the 50 part, you can keep doing numbers farther and farther out. Like you could do a 100. So if I tried 100 here, that would be 50 times 100 plus 30 over 101. So 50 times 100 is that, plus the 30 divided by 101. Grab my calculator. So on, and I get 5030 divided by 101, and I get 49.8. So you can see that I'm getting really, really close, way out there, but I'm not touching 50. So then what happens on the other side of our asymptote? That's where we need to plot a whole bunch more points. On the other side, so I would be at like negative 2. So I'm going to have my t sub 1 and my b. If I'm at negative 2, so that would be 50 times negative 2 plus 30 over negative 1. So that's going to make this a negative 100 plus 3. And 2 negatives are going to make that positive, so that's going to be a negative 97, so positive 97. So I am at a negative 2, and I'm at a positive 97. So I'm way up there. And my graph only goes to 80, so this would be 90, and this would be 100 up here. So I would be approximately there at my negative 1, or negative 2. I can try negative 3 and see what's going to happen if I'm going to continue to go up, or if I'm going to start coming down. And remember, we had this asymptote going right through there. So negative 3, that's going to be 50 times negative 3 plus 30. And negative 3 plus 1 is a negative 2. So this is a negative 150 plus 30, which is a negative 120. Negative 120 divided by negative 2 is a positive 60. So I am coming down. I'm at negative 60, negative 3. So that's down here. So then I'm going to try a negative 4. So that's 50 times negative 4 plus 30 all over negative 3. So 50 times negative 4 would be negative 200 plus 30. And negative 30 plus would be negative 170. Negative 170, so 170 divided by 30 is 5 2/3. Oh, divided by 3, 50 2/3. Or, nope, sorry, it'd be like 56 2/3. 56 2/3. So 56 2/3. Get that one plotted in there. I'll just erase my point. Put my point back. So that was at negative 3, I am at 60. So at negative 4, I am at 56. And you see we're kind of shallowing out again when we get close to 50. So what happens at like negative 10? So that would be 50 times negative 10 plus 30 all over negative 9. So that's negative 500 plus 30. So negative 500 plus 30 is a negative 470. And then you're going to divide that by negative 9, and you're going to get a 52. So you can see that we're getting close to our line there. And again, we're not touching it way out there. So our curve is going to come down here, and this asymptote is going to go the whole way across. So then after that, what is the v-intercept of the graph? Our v-intercept is going to be down there at negative 30. And what values of t1 and v1 are meaningful in the contents of this problem? Well, we've got two asymptotes going on here. So when our v is equal to 50, we've got an issue. And when our t1 is equal to negative 1, we've got another change. So that is actually when we're changing velocities and what our velocities, originally was.